Then finally, we need to be able to process the data once we've done our calculations. So in order to determine the volume of the analyte added, you find the concentration. So you already know the concentration, but you don't know how much. So you need to use the equation N equals C times by V to find the number of moles of the analyte at the equivalence point. And so the number of moles of the analyte at the equivalence point is going to be equal to the number of moles of the titrant. And so this is because we know that we have the Henderson-Hasselbalch equation, and that tells us that pH equals pKa at half equivalence. So we can use concentration equals moles over volume in order to find the concentration of the titrant. And so this is because you've already got the initial volume of the titrant, and so then you can use moles equals mass over molar mass to determine the mass, if that was then required, if you were adding in a certain amount of solute into the solution. We also need to consider how we create a standard solution. So that's going to be the solution of known concentration, which is in the burette. And so there are a few main qualities that must be considered in order for a good standard solution to be prepared. So the main points which we have with these that we consider would create a good standard solution are if it is highly water soluble, it's a pure solution, it doesn't absorb water from the atmosphere because you don't want part of the measured mass to be water, otherwise it will impair the accuracy. You need a known and consistent chemical formula. It needs to be stable and non-reactive to the atmosphere. And then in terms of it being in an industrial chemical situation, you want it to be relatively inexpensive. Otherwise, if it was being done in an industrial situation, the negatives would outweigh the benefits. So in order to create the standard solution, first of all, you need to measure the mass of the solid to be used as your analyte. And so this is very important because if you get the wrong mass, you can dilute it later, but you can't make up for the inaccuracy caused by the inaccurate measurement. Then you need to dissolve all of the solid in distilled water. Then you transfer it to the volumetric flask, add some distilled water to rinse the initial container clean of the solid if needed. And then you fill the flask until it reaches the volume line, and adding dropwise amounts until you reach it so that it's very accurate. Then you place the stopper on the flask and invert it to make sure that it's all mixed evenly.